Hey guys, so this is take two. The first screen recorder I was doing cut me off after 5 minutes and I was totally in the groove. What a bummer. Anyways, today we're going to be working on our light notes. So in your assignment, this is linked. And with the light notes, you can do a few different things. You can print them out if you like to and you have access to a printer. You can do them digitally. And so if you do them digitally, I'm going to suggest that you do a split screen where you have your notes on a screen over here, and then you'd have your video playing over on this side. Um, or do two devices where you have your video playing like on um, one screen and your um, notes happening on another screen. Sorry. And then the third option is to just make your own notes. Oh, sorry, I was going to show you. If you're going to fill these notes in digitally, you're going to need to do File and then click Make a Copy. And then you can name your own copy and save it in your Google Drive. If you haven't already done this in your Google Drive, I really recommend setting up a folder for each class to save your files and then reorganize the files you've been working on and putting them into your different classes. So it's just like having a binder, but having a digital binder. The last thing you can do is just take your own notes. You don't have to use this template. You can do doodle notes. You can make a flow chart. You can make a bulleted list. You can draw in pictures. Whatever works for you. Just keep in mind that you can use whatever notes you make when you take our tests and quizzes. And so having good notes is really going to help you be successful. In our lesson today, we're going to be learning about what is light, how does light travel, what are light wave interactions, and how the sun's energy gets to Earth, and then what happens when light hits an object. It's kind of a lot. Maybe we'll take a little TikTok dance break in the middle. We'll just have to see. All right, so light. I'm just going to pull this screen down a little bit here. Maybe not. All right. So, light, what is it, anyways? It is energy emitted by the sun. Remember a couple months ago, we were learning about what is light, we were learning about different forms of energy, and we were learning, we learned about sound energy, electromagnetic energy, light energy, radiant energy were all the same thing. So now we're really going to go into the specifics of that one type of energy. So, um, the biggest difference between light and sound is that light travels through empty space. It doesn't need a medium. So it doesn't happen from one particle crashing into another particle and transferring like a sound wave does in a longitudinal wave. Instead, you can't see it, but there's all these electromagnetic fields around us all the time. So you might have remembered in elementary school learning about how like the earth is a giant magnet and there's magnetic fields around the earth, and there's also electric fields around the earth, and this is how things like your Wi-Fi work. This is how wireless phone calling works. And so what happens is you have electric fields and magnetic fields. So if you break this word apart, electromagnetic, you're causing vibrations in the electric fields and the magnetic fields, not in particles. And so because of that, light does not need a medium to travel, and it can travel in empty space, which is why we can see the sun, but we can't hear the sun. I would imagine the sun is really loud, right? It's probably like a big erupting hot ball of fire, volcanic explosions, etc. But we don't get to hear it because sound doesn't travel through space. But luckily, light does. So light is super, super fast. I'm not going to really go into it, but it is the fastest thing that we know on Earth. And it takes it takes 8.3 minutes for light to get from the sun to the Earth. So everything that you're seeing from space is really like not what's currently happening in space. It's kind of like watching instant replays. So light travels straight. It's like coming right at you, but it doesn't come at you um, without making some wave disturbances. So even though it's coming straight at you, it's actually moving as a transverse wave in both the electrical fields and the magnetic fields. So it is a transverse wave. Remember, transverse waves get tall, longitudinal waves get long. And so, um, yeah, that's what we're talking about because it's waves, and that's what we're talking about. So light interactions with matter. So basically, anytime light gets out of that empty space and comes in contact with a different type of medium, right? So it's going from like air to water, or air to my clothes, or from empty space into our atmosphere. It can do a lot of different things. So it can be um, deflected, distorted, or changed. And it can do basically 6 different things. So it can be transmitted through something that's clear. It can be reflected, like off of a mirror. It can be refracted, which is what we were trying to see yesterday, where it was bending as it was going through the different mediums. It can be diffracted, which is when it like basically is diffused or spread out in a bunch of different directions. And it can be absorbed, and it can be scattered. So in absorption, um, light waves transfer energy to the particles of matter. So have you guys ever heard the thing that like black cars get really hot? Or have you ever noticed like when you get into the car in the summer and how the fabric or the leather or whatever your inside of your car is, or the school bus seats, are super hot? Well, what's happening is we all know that light is a form of energy. And so that light comes down like boom, and then it gets absorbed into the particles, and then the particles start vibrating. And if you remember, vibrating particles is otherwise known as thermal energy. So you're going to get heat. And so when light is absorbed, you're transferring the energy into the material. And black absorbs all the different wavelengths of light, all the different colors. And so black gets hot faster because white reflects the light and not a lot of it is absorbed. And so that is really true when they say black cars get hotter than white cars. And that's why people prefer to buy white colored cars, because they don't get as hot in the summer. That's why people like to wear white in the summer. Um, so when incoming light hits an object, it causes the atoms to vibrate, and then it converts the energy into heat, which is radiated or given off, right? So again, that light wave comes in and it gets absorbed in, and then that wave movement is going to cause the particles to vibrate, and vibrating particles is thermal energy. So when the light hits a non-reflecting surface, right? So not a mirror, not smooth water, it's going to get absorbed. But this is where the whole idea of color comes into play. So everything gets absorbed except the color that the object is. So instead of the light waves bouncing off the surface, they are, and oh, let me restart that. So all the colors of the light come in, and all the colors of the light gets absorbed except for the color wavelength. That specific energy level is not going to be absorbed by the banana because it's being blocked by basically like the thing that's making it yellow. And so then the yellow is reflected back to our eye, which is why we see red. Or in an apple, it's going to absorb all of the colors except for red, and then red is going to be reflected back to our eye, and that's what we're going to see. So most of the energy is being absorbed, and a little bit of the energy is going to be reflected. So yellow bananas reflect only the yellow part of sunlight, but absorb light of all the other colors. Transmission occurs when light waves pass through an object without interacting. So they just go straight through like a window. This is only going to happen when you have like a clear, transparent surface, right? Refraction is the one we were learning about yesterday when we were looking at rainbows. The change in direction of a wave when it changes speed as it travels from one material to another. So what should have happened yesterday is you would have seen this light coming into your glass, and it helps if you put the flashlight at an angle. It's going to give you more bending of light. And then as it goes through this, it changes this barrier, it's going to cause the light to bend, which is going to split the colors into its different wavelengths, and then you should be able to see a rainbow. So that's refraction, and it's when the wave changes speed as it's transferring from one material like air to another material like glass or water. Reflection is when the light wave bounces directly off of a surface. So the reflection is like bouncing off, and it's going to come in and go out at a 45-degree angle. But when you have like a distorted image, right? Like if you go into those house of mirrors, or you're looking into maybe a reflection in water and it's not a perfect mirror image, it's because your reflection isn't coming off straight on a flat surface like this. It's getting kind of wavy, and then that's going to kind of distort the image. But no matter what, reflection is when the light waves bounce off the surface. So scattering is an interaction of light when matter causes light to change direction. Light scatters in all directions. And so here's the magical question that kids always want to know. So why is the sky blue? I mean, when I color a sky, I like to make it pink. Who decided it had to be blue? So the sky is blue because the scattering of blue light by gas molecules in the atmosphere. So there's things in the atmosphere, right? There's ozone, there's oxygen, there's nitrogen, there's different types of pollution, there's carbon dioxide, there's all kinds of things in the atmosphere. And when the sunlight is going through those things, those are also barriers. Those are also things that are causing the light to have interactions. And the light is scattering off of those particles. And what we're seeing is the blue and a little bit of the green light gets scattered. And the rest of it is just transmitted straight through. So how is reflection and scattering different? So if you shine a narrow beam at a highly polished surface like a mirror, you get a narrow beam of light reflected back. So you get a really clear image. If you shine a narrow beam of light at a rough surface, like the rough surface of all the different random particles in the atmosphere, the light scatters in all directions. So it's kind of weird to think of a gas as a rough surface. But if you think about what it looks like at the particle level, the particles are not lined up all smoothly next to each other. They're like randomly placed and moving around. And so then when the light randomly hits one of those particles, you're going to get that scattering, where a mirror surface would be like solid, right? So particle, 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 all perfectly smooth and lined up. So when the light comes in, all the particles are going to react the same way, and it's going to be at the same even surface. So scattering is when you don't have that perfectly smooth surface. Diffraction occurs when waves bend around a barrier. So you can see a ring around the moon. Sometimes you can see that ring around the sunset, kind of that halo effect. That's when you're getting diffraction. So here's a good kind of image to summarize up what we've been talking about. We're not going to finish these notes today. This is going to be enough, so you can stop here and then we'll finish the notes tomorrow. We are going to do a little vocabulary practice, so please check in to see what else we have for you in Schoology today. Thanks so much, you guys. Looking forward to hearing from you soon.